Hi guys, and first of all, welcome to my channel, both those who are returning to my videos as well as those who are new subscribers. I guess that you do like my videos, so I've decided to actually make a proper video where I explain everything, all the ins and outs, from start to finish, and you can follow along and also copy some of the stuff that I'll be providing in my Google Drive folder. My shared Google Drive. So, I thought about where to start first. Should I start from the plane? Should I start from the radio? Should I start from INAV? And I think the best thing to do is actually to start from the radio itself. Show you a little bit about my setup so that you can follow and have everything as I have. Of course, you can copy the model file. Just keep in mind that if you have a newer version of EdgeTX, you might have to modify a couple of things. This is because there have been quite a lot of changes in EdgeTX, but I haven't moved on because I like the old user interface. I don't quite like the new user interface, so my EdgeTX is on version 2.7.1 with a custom boot screen as well as some custom buttons like this one, because I wanted to have that as Radio Master, RM. Anyway. Let's look into the model where you can see a bunch of interesting things. I've disabled heli because I don't need it, but let's scroll down directly into my setup. You can see that unlike what many other people suggest, I've got my input section with all of my channels, and then I've got my mixes section with all of my mixes. That's just because this is how it's supposed to be. We're not supposed to have direct inputs into the mixes. We're supposed to have inputs in the inputs and mixes in the mixes. And a lot of tutorials that I have seen online in the past have always gotten this wrong, so I think that this is the way it's supposed to be. It's also better because it's more visually appealing, right? So if I hit the arm switch, you can actually see that we are changing between the two conditions. The way that I always set up all my channels is I've got both the switch, so this is the switch that I'm switching this mode into, as well as the source on the same channel. So the source is basically just dictating where this will be, and the switch is what's actually switching that particular channel. And this is the way all of these have been set up. My channel 5 is obviously the ARM switch, that's mandated by XpressLRS. Then I've got a stabilization mode switch, which changes from manual mode to acro and horizon mode. I'm not using angle mode because I think horizon mode is good enough for the things that I'm using it for. I've got my position hold and return to home on this switch right here. The middle obviously being no assignment. I've got always the 1, 2, and 3. And then for this particular plane, I've got 3 VTOL modes. In the other model, this would actually be changing the flaps. But since the flaps on this particular model are actually connected directly to the tilting servos, I have used this for my VTOL. So we've got the normal mode, which is plane mode, transition mode, and vertical mode. Maybe I'm gonna rename these into plane, transition, and tricopter, but anyway, doesn't really matter. Since this plane does have, as you can see, a small gimbal, I do have the need to have pan and tilt. The way that I've set up my pan and tilt is basically there is a switch on the back of the radio, which is an additional switch which you can install both on the Mark 1 and the Mark 2, I think. I'm not sure. I know that the Mark 2 has been designed for this switch because there's a plug when you buy the radio. You can get the switch from pretty much anywhere. It's just either a momentary switch or a latching switch. Plenty of videos online on that. But basically what happens is when I switch the switch on, I've got 2 options for controlling the panning. I can either control the pan using the LS slider here on the side, so either that, or I've got a function which is logic condition number 9. This is why you see that little exclamation mark, because all that says is basically when logic condition 9 is not active. And when it is active, then I'm switching to my head tracker input, which is going through the trainer port, and that's why it says here TR1. And I can switch between the two modes, so between moving the slider on my radio or between the head tracker pan input, right? The same goes for the tilt. Same story here, except that here it's TR2 because that's how I've set up my head tracker. The head tracker that I'm using is the Bluetooth head tracker, which I think almost everybody is using, with mine just being a little bit different because I'm using a tiny little board on top of the goggles. I'll show that in another video, and it's really easy to set up. It's just like the other head tracker. The only issues I've had with that is that sometimes the range isn't great because the Bluetooth chip is actually here mounted to the side of my radio. You can see that in another video. Post a link in the description if you want that for reference, or you can browse through my channel and see it there. But long story short, it's not great because I think the Express LRS 2.4 gigahertz is kind of overpowering everything in the area, and then this little device stops working. But anyway, so it's partially working. Then I've got my flight modes. Now with the flight modes, it's a bit of a thing where I've set up, I wanted to have 4 flight modes on one channel, and the way that I've set them up is I've given priority to the launch mode and cruise mode over the waypoint mode and autonomous landing, and I've done a video on autonomous landing as well, so you can have a look at that. It's just landing in a straight line with this exact plane, but just the normal version, so it's not the VTOL version. So there we need landing in a straight line, and then when I switch both of these switches off, it goes into NA, which is not assigned. Here I've got my head tracker, pan and tilt. These are just so that I can monitor the channels and how they're being input, because as you can see, these ones have a weight of 100, whereas if we go to the tilt here, you can see that this just has a weight of 90, because 90% is enough. 90% for the pan and 80% for the tilt was enough for me to give the correct motion, so that when I turn my head 90 degrees to the left, right, up or down, I actually get 90 degrees on the gimbal. This is something that you'll have to fine tune. I'm not going to go into that because I don't think that's important. In my mixers channel, or sorry, my mixer section, I've just got everything laid out once again. The only difference being that I have mixed in an elevator trim, which is basically this here, and all that this does is it gives the elevator trimming in horizon mode the benefit of having an autonomous climbing feature. So when I want to gain altitude and I don't want to hold the elevator stick, I can just put the plane into horizon mode, trim it either down or up depending on where I'm going, and in this case it will be towards the down position. There we go, and that will give it a fixed down elevator. And the reason why it's limited to 50% is because horizon mode, in my case, has an angle limit, and the 50% is as much as I can give before the plane starts doing a roll, because horizon mode starts doing a roll as soon as you go beyond 50%, so that's why that's 50. Next, we'll have a look at my outputs. Now in my outputs, I have done a bit of modification. I don't like to use 100% because that doesn't give me 1000 to 2000 picosecond ranges. It actually gives me slightly larger ranges. I don't like using them because some of my logic conditions in INAV are related to this. So anyway, that's the reason why that is there. In flight modes, or global variables, I'm using the flight modes global variables to do the zooming in and out of the maps, as well as selecting and adjusting PIDs while I'm in flight. Now that is not available for this particular model. It's available for the standard model for this plane, because I'm using those same channels that I use for the selection of which item to pit tune and the adjustment channel for my head tracker pan and tilt. So these are actually not available in this model, but they are available in the other one. I've got a bunch of logic conditions. I'm not going to go through those because I think I'm going to bore you if I do that. And then there's a couple of other things here, which I'm not going to go into detail because I think I have already done a video on that. Telemetry is, as it says, telemetry. If you follow any of the other tutorials, you'll see that all you need to do is, if you don't have this, just delete all of the ones that you have and then just discover new after you have connected your craft. That's all it is. So that's basically everything that's to do with the radio. I don't want to go into too much detail. This was just a brief overview of everything that's there. I will now get on to the INAV stuff because I think that's a little bit more important. And I'll show you the full setup of the Hewing T2 Cruza VTOL. So let's continue with that. Alright guys, so now let's have a look at the setup and let me show you how I've set these up in full rather than just a brief explanation, although that was a 20-minute video, but now we will do the full setup. And that is the fact that my flight controller has decided to disconnect itself. Just fine. That's just because it's switching between the power supply from my power supply and it being powered by USB. Don't know why, but this is an old flight controller and it does have that issue. It's end of life for a good reason. So let's just power that in. By the way that I'm using any desk setups is I've got a HP charger, I think, or a Dell charger, no idea what it was, but anyway, with an XT60 lead at the end, so I don't have to use a battery when I'm doing my setups. I recommend you to have something like this so that you can make your life a bit easier. Anyway, so here we are in INAV. Now everything is connected, and obviously if you have done an INAV plane before, you know that the first thing that you need to do is to calibrate your accelerometer. If you do have a compass, it would be a good idea to calibrate the compass in the field, but you can do it at home if where you're flying is not too far from where you are. The mixer is basically a copy of the INAV mixer and what's there. But what we'll do today is we will have this mixer set up from scratch. So all of these I'm going to revert back to default settings, and then we'll get to our desired result in just a moment. The output section is standard as well. Just keep in mind that when you are, whoops, there we are. Just keep in mind that when you are in plane mode or fixed wing mode, you should have the motor stop on low throttle enabled, because otherwise the motors will be spinning. Unlike when you are in tricopter mode, you want to have this disabled. In the ports tab, I have connected my rangefinder, GPS, all the things that I need. I also have S-Bus output because I was testing the gimbal and whether it might work with S-Bus. Unfortunately, that didn't work, so I'm just going to go ahead and change that to previous because it just didn't work, unfortunately. The gimbal can be connected via S-Bus, and I have managed to get it working via S-Bus. It's reading the S-Bus channels, but for some reason, it's just not working. I'm not sure whether an update to the firmware of the gimbal will resolve this, but anyway, I'll not go into that for now. That's a topic for a different video. So we just hit save and reboot. And we're back into the ports tab. In the configurations, there isn't much going on. I've just selected my magnetometer, barometer, the rangefinder which I'm using. I've shown that I think in another video. It's basically just one of the hatches that are on the bottom of the wing. I've just made a custom hatch. I'll post a link from the Thingiverse that I've uploaded. You can just download it, print it, and then just kind of jam that rangefinder into the wing. You can use the spare port that's there, but I'll show that in the video later on when we look at the hardware wiring and all of that. Failsafe is obviously set to return to home. I'm not looking into easy tune, pit tuning. I'm not going to show because that's not part of this video. But these are the standard PI and D gains for the VTOL setups from INAV. I haven't managed to tune those yet. Probably I will get to tuning them at some point, but just not yet. In the advanced tuning tab, for the standard plane, so not the VTOL version, I have made just a few tiny little adjustments because that one does not have a rangefinder. So just something that I changed. If we switch into the fixed wing profile, we can see that for the autonomous landing, and I can see that the advanced tuning tab has not switched from multi-rotor back to fixed wing, which is interesting. But there we go. Now you can see my fixed wing items. That's interesting. I guess that's a little bug because you see it stays in multi-rotor, whereas it should stay in, it should go into landing for fixed wing. Maybe I'm wrong. Anyway, under programming, I just have one condition, which is I want to be able to arm the craft even when I don't have GPS satellites and when my throttle is low. So you can see that when I raise the throttle, this condition becomes inactive, and now it's active. So now it will allow me to override the arming safety, but I do have a safety switch to that, which is I want my RC channel to be below 1005 so that it doesn't receive any throttle input before I actually arm. In the receiver tab, we can see that everything is as standard. Here we can verify our channel. So channel 9 is the channel that I'm using for my mode switch. You can see that in the modes tab as well. You can copy this from my diff if you like. If you want the exact same setup, you can just use that. And here it is, the mixer profile and mixer transition, which we want. So mixer transition is basically when the switch is in the mid position. When it's in the high position, it's just mixer profile 2, and we can switch back to mixer profile 1. Under adjustments, I don't have anything at the moment, but I would be using the adjustments, as I mentioned previously, for my in-flight pit tuning. There are other videos which have explained how to do this. I've done it in a very similar way. You can do it via a potentiometer, you can do it via trim switches. There's a bunch of ways on how you can do this. I'm not going to go into the details of that because I think that's a completely separate topic. But anyway, with the alignment tool, I'm just having a look at my at the direction of my magnetometer, and for this particular GPS, which is a Bayesian BE252Q, it's a great little GPS, very moderately priced compared to stuff like the Maytag receiver, which is smaller in size, but has, I think, inferior reception quality. I've had a lot of issues with that receiver for some reason. I don't know if mine is faulty, but I have two of them, and both of them perform exactly the same way. This one I'm very surprised by because this is the first time I'm using it. I'm using it on this model. I'll put a link into the description. It'll be something from AliExpress just so you can grab the name, but you can get it probably from anywhere. It's a really good GPS, fits perfectly in this model and has excellent performance. I've had 32 satellites, which I have never seen on any of my other GPSs. It's really excellent. The positional accuracy with 30 satellites is almost like having an RTK GPS. Not really, but you know what I mean. For those of you that don't know, RTK GPSs are just corrected GPSs. So they're very high in accuracy, but they do require a ground station. In the OSD setup, you can see that I have quite a lot of things. It's a relatively busy OSD. If I switch to those things, switch? No. So that's my default OSD. My default OSD is very busy. There's a bunch of stuff, and there's even something that I will add now, which is the VTOL switch. So if we go down to switch indicator 1, I have added that VTOL indicator, which I think is important for this plane, and I didn't have that before. So in the diff that I have already provided from my previous video and in this video below, you will see that that's probably missing. However, you can just add it. It's nothing special. I don't have any LED strips set up for this plane yet. I might do in the future, but basically that's about it. So that's the INAV setup in total, and what we'll be focusing on will be the mixer section, because I think that is the one where you will have most questions on, and since this is a VTOL video, this is where we'll be focusing our attention on today. So let's have a look at the INAV documentation. Now this is my version of the INAV, my fork of the INAV development. I have just made a small change for which there's already a pull request on INAV, and I hope that they do accept it, because there is a photograph which hints at this but doesn't go into a lot of detail as to how this is supposed to look like. So what you see currently on INAV might not be what you see on my screen here, and that's just because I have slightly changed a few things. Okay, I follow the guide mostly, but you will see that there will be one section which we will have a look at together, which you can follow and set up yourself as well. So if you follow step 0, step 1, and step 2, or step 1 and 2 as they currently are mixed in the official guide, it should get you to a good point. And what we will do now, just for the sake of, I guess, running the setup fully, we will set this up from scratch, and because it doesn't talk about outputs, I'll just leave those, and we will get those values manually the same way that I got them when I did my first setup. You'll see the servos move now, and there we can see what you might be faced with when you start your setup. So let's go into the mixer tab. Here we have the plane mixer, and if we switch to the tricopter mixer, you can see that I have changed these values here as well, and I'll change them back to the default setting, just so that everything is exactly as you would have it. So, just following the guide, not doing anything special at the moment. You can see that mixer transition has been set to 45, and here mixer transition has also been set to 45. The max value has been set to -87, but you see They haven't really explained why this is minus 87 and why this is minus 85. Why there's even a difference, I'm not sure. Maybe the person who did the setup on this particular tricopter hasn't set it up correctly. Could be. Anyway, this is my section, the step 4 for the setup of the tilting servos. And let's just have a look at that. Now, obviously you need to know where your channels are plugged in, right? So that's not gonna work if you don't know what you're doing. So follow JB's video if you want to see how to set this up from scratch. I don't want to do a repeat of that because you can just watch his video. But essentially all that you need to pay attention to is because we have a third motor which is currently not plugged in, but we do have a third motor. You need to set up one of your timers to do motors. In addition to S1 and S2 timer being for motor 1 and motor 2, you do need motor 3. Now, conveniently for my particular setup, I do have 2 slots for timer 5, so I'm only losing one servo output channel because I don't have a 4th motor. But if your setup looks slightly different, you just have to adjust these to make sure that you have the right number of servo channels and the right number of motor channels, and these will set themselves up correctly. I've literally just followed the guide and I've had a look at the screenshots as they are, so these values are a direct copy of what you can find from there. When we have a look at this, you can also see that everything is the same. This is where I don't know if you saw that glitch there. That's probably not supposed to be either way, but it could be related to the switch on the radio. If that happens, I don't know. I guess we'll find out if it happens in mid-flight. But here we are. So now, as you can see, these are only tilting forwards. There's no tilt in the backwards direction. And the reason for that is because one of these values has to be plus and one of them has to be minus. If I remember correctly, the bottom one is supposed to be, the top one will be minus 50 and the bottom one will be plus 50. So let's just set that up. Yep, and that's correct. And we can check whether that is true, because when we yaw to the right, this motor is tilting forwards, which means that it's rotating the plane in that direction. So basically like that. And then when we yaw to the left, the other motor is tilting forwards. So now we know that the tilt is in the correct direction. If you have a look at the tutorial, step 4, it will be actually the last step for adjusting that, but that's also part of the tilt of the servos. So anyway, the sign of this you can adjust at the moment. Leave the values at minus 50 and plus 50. Now if we have a look, if we zoom into this a little bit and we just have a look on the side, we can see that this servo is relatively good, but the servo on the back, let me try to show that, is not really perfectly vertical, right? So that's an issue that I've been having for some time now, because I think that there's just a problem with these servos. They don't line up perfectly vertical. Although they look to be perfectly vertical, I can tell you that the one at the back is actually facing slightly forwards, and you can even see it from this angle. Let's try it like that. You can see that the blades at the back are slightly tilted down, right? But we will correct that in just a moment. So the first step in this is to set up your min and max values in your outputs for those particular channels. In the previous video, I didn't exactly specify which channel and so on and so forth, because I thought that it would be obvious, but probably it's not. And so now let's have a look at our outputs. You can see that this is 1000 and this is 2000. That's because these servos are mirror image to each other. If that mechanism was on the other side and you had installed the servo exactly the same on both sides, then it would be 1000 and 1000 or 2000 and 2000, depending on the position of the servo that you're in. However, the most important part of this setup is actually to trim the servo in such a way that when the motor is in this position, it's just about touching the back there, and that's what we'll do. So in my case, that should be servo number 4, I believe. Let's try with a value of 900, and you see that moves it back. Let's try 850, and this is trial and error. So now you can see that that's definitely touching, and to make things a bit easier, I will just zoom into that like this, and I will be changing the values, slowly increasing to get to the desired result. Let's try 75. Okay, 75 is too much. Let's go a little bit further. So let's try 60. Almost there. Probably 65. It's either 65 or 70. Let's just move that a bit. Let's try 70. $60. 55. Right, there we go. So now, when I move this, you can see it's just touching. Now we want to remember that value of 855, but we can leave it for now. The reason why I'm saying that is because now, you see, when this is spinning, it's actually touching. We don't want that, okay? But we will edit in just a moment. Now it's time to do the other side. Let me move the camera and just readjust that position. Let's focus on the back there and do the same. So in this case, it will be a greater value than 2000, and we can try 2200 maybe. Right, so obviously that's a bit too much. Let's try 2150. And that's too little, because now if we have a look at this, you can see that the prop is, oh, actually that's not too bad. Seems just about right. Maybe we can just decrease that a tiny bit. There we go. So it's now, it was just about touching when we were at 50. And that's what we want. There we go. So when we move this, you can see it ends up just about touching. So now we know that both sides are the same. Let's move back to this side here, because what we're going to do now, there we go. So what we're going to do now is we will basically increase or decrease these values by a fixed amount on both sides equally. So now that we know, so this is without using any gauge blocks, etc. This is literally just kind of eyeballing it, okay? This is the best that you can get without using any gauge blocks or stuff like that, or measuring and making your life a bit difficult. So what we're going to do is we're going to increase both sides by 30, or increase and decrease by 30. So this side is going to become 885, and the other side is going to become 2120. So now you can see that both of them have moved up equally, or maybe you can't. Let's just zoom out so that you can see both sides, the one there and the one here, have moved up the same amount, okay? And the reason why we want to have this clearance at the back is because, as you know, these props are flexible, and when they're rotating, they are flexing to a certain degree. So we want to leave at least a little bit of a gap. This is as much as it is for reference. You choose how much you want to leave space. This is something that I'm personally happy with. And what we can also see is that when we align the plane like that, we can clearly see that both of them are pointed at the correct angle, okay? So this is the first part, so to say, of the setup. You want to make sure that this is where you are for now, because the next step will be to switch into the forwards motion. However, to do that, you want to make sure that you rotate your props, because otherwise it will just crash into the ground. Like this. There we go. Now, trimming this part is a little bit more difficult because you do need some calipers. So just by eyeballing this, I'm just going to get it almost perfect, and then in time I will try to use some calipers to make sure that it's perfectly aligned, and I'll show you that step in just a moment. So let's go down. Now we are in the opposite direction, so now we need to trim this value, okay? So because 2000 is a value that's a little bit too low for this servo here, so servo number 4, we want to make sure that we take that and decrease it slightly. Let's try 1950. That's not too bad. And the other side seems to be okay, but we do need to have a closer look at that. So let's just move the camera temporarily to somewhere like this, where we can clearly see what angle that's making. And I think that is almost perfect, but we do need to make sure that it's perfect with some calipers. So we will first of all get one side exact, and then we'll look at the other side. Okay, so firstly I'll be looking at this side here, measuring two things with my calipers, and I'll show you in just a moment what that is. So here we are, calipers are right there. I'm gonna have to do this inverted because of where I'm measuring. So what I'm doing is I'm just measuring the gap here and from the underside. It's a little bit difficult to do because obviously you've got your stuff that's in the way, but it's still possible, and because of the parts being machined relatively well, we can just easily do this. So shows 8.15 millimeters, and if we look on the underside, which is definitely harder to do, at least for the purposes of a video, we've got I don't know if you can see that value, but let me just zoom out a little bit. We've got 8.84 on the bottom. So that means that now the servo is actually pointed upwards, okay? So we want both values to be the same. That's how we know that the servo is actually correct. So let's increase that to 75. 1975. I think that's a bit too low. Maybe 1965. You might want to move the servos up and down just temporarily, because they can get stuck in a slightly awkward position, and then when you measure it, it turns out to look wrong. So that's 845, and on the bottom, .7. So we're almost there. Just need to point it down a tiny bit more. So to go down, we can just go down to 70. And let's just measure that again. So that's 8.51, and I think that it will be .57. There we go. So I think getting it to the second decimal is good enough, right? Now we need to do the same thing with the other side. But in this case, we're looking at the min value. So let's just transfer the camera to this side. Let's see what we've got with the current setup. It's a little bit difficult to do when you're recording this, especially with the plane not being quite in front of you. So we are at 8.24, but we know that we need to be about 8.5 millimeters in this case. So we can only adjust from the top side, because we know that 8.5 is like the correct distance, 8.55 probably, because that was the average between the two previous values. So what we can do is we can point this down a little bit more, so it will be something like 995 perhaps. And let's see what that gives us. That's 832, so probably 990. And I can switch between the positions just so that we get the correct measurement. There we go, 8.4. So another 5, which brings us down to 985. Just a quick switch. I think that we can safely say that this is okay. Maybe just move it by another 5, should be okay. So 980. I'm not sure what the values were before, because I've deleted those and I don't want to look at the diff to cheat my way through this. I just want to have a look at doing this from scratch as you would in your case. And there we go. 8.57, which I think is good enough. Okay, so I know that both of them are slightly tilted downwards, but that's okay. I don't mind that. I would rather have them tilted slightly downwards than tilted upwards, because otherwise what they'll do if they are tilted upwards, they will pull the plane up. Now comes I guess one of the final steps of this, and this is the probably slightly tedious step. So if we go back into the mixer, we can switch to the tricopter mode, and as you can see, that is pointing our servos back. But here is what we need to do. In order to have them actually tilted vertically upright, these are the two values that we need to change. So at the moment, we've got a max value of -100. Now, I remember that this value was -83, but just for the sake of doing the tutorial, I will put -70 in both so that you can see what happens. So you see, both of them have now moved into the forwards position, or slightly forwards position. And what we really want now is just to make sure that this is truly pointed vertically up, right? So we'll go to 80. And that's almost perfect, I would say. Since the range of motion for both servos is exactly the same, these two values also have to be exactly the same, because it's 80% of whatever the previous value was. So let's do 83 as what I had before, which I think should be the correct value. And there we go. So that looks perfectly perpendicular. It would have been helpful if Hewing, like on the VTOL kit for the T1 Ranger, if they actually had some indices on the side. But what you can do is you can measure the thickness of the servo with your calipers, like so. Let's just squeeze that value in so we don't lose it. And that is 22.5. 22.5 divided by 2 is 11.25. So if we move this to 11.25, oh, just about moved. Okay, anyway, there we go. It's in between, okay? So 11.25, 11.24. Then what we can do is we can put this on the side and just rest it right there and just mark out like a little scratch that we can then have a look from the side and see if that aligns perfectly with our mark right there. You see what I mean? So you just scratch the servo a tiny little bit and then you know that that's the center. So you can just use that to help yourself in aligning these servos, because Hewing have not engraved a mark. It would have been great if they did. I hope that in a later revision of this they actually do this, and then we can all have a great time. So we have almost completed the setup. There's only one final thing that we need to do, and that is to adjust the range of motion. And what I mean by range of motion is basically the stabilized yaw weight values, because let me show you what happens. Let me try and tilt the camera up a little bit, like this. And let's zoom out so that you can see what's going on. Now, one of them, you see, one of them is going back, it's going back, it's going back, and then it stops right there, but the back still moves. You see the same in the front, they move, but you see the one at the back has already stopped moving, and there is still motion to go for the front or the left side, right? And that's not what we want. We want them to move equally. So in order to adjust that, we just have to go to the weight. Let's start with a value like 30, or in this case -30 and 30. Save and reboot. Unfortunately for the mixer, you always have to save and reboot. You can't just save like you can do in the Outputs tab. And with 30, we can see that both of them move exactly the same amount, as well as one of them doesn't continue its motion at the end. However, I think that 30 is not enough for this, because I previously had 35. So what we'll do is we'll give it a little bit more motion, which gives us a little bit more yaw authority. And we'll just increase that value to 35. Of course, it will depend on your model what that value will be, but I'm just showing you what the procedure is on how to get there. So you can see that gives us the full range of motion for the servos. If I go any higher than this, I know that one of the servos is going to stop moving before the other one does, because it will have basically reached its end point. And that's it. That is the full setup, right? So if you follow these steps, then you should be at the same point as I am right now. I may have done things in a slightly different order than what's written here, but the main point is that this is what you need to do. This optional step that I have at the end for reversing the tilt servos and the mixer signs is something that I did in the beginning because I knew I would have to do it. In your case, that might not be the case. You may not have to reverse any servos, so that's why it is left as an optional step and is not a mandatory step. In either case, I hope that you enjoyed this video and that you can now see a more detailed, more elaborated and fully explained way of setting up your tilt servos, as well as a little bit on the INAV setup itself. What we'll do now is we will end this part of the recording and just have a look inside the plane, because there are some crucial things which I think are noteworthy, and then we'll have a look at some 3D printed parts, etc. for this particular plane. You don't have to watch those parts of the video, of course, but if you are interested, then stay tuned. So I'll be back in a second. So let's have a look at the wiring inside this plane and what I've done, just to give you a brief overview. First of all, something crucial that I'd like to mention is that Hewing, when I bought the plane, have provided a 16 AWG cable, right? So I don't know if you can see that there, but that's a 16 AWG cable, and it gets hot, okay? The cable does get moderately hot, I would say. It's not warm anymore, it's not moderately warm, it's moderately hot when you are in tricopter mode. I'm sure that it's fine in all the other modes, because on my other T2 Cruza, I have the exact same cable and it's okay, it's behaving fine, it's not getting hot. But with the tricopter configuration, I think because of the fact that these ESCs and motors are just sucking more power, things do get warm. And so I have changed a few of the cables inside, and I think you should as well. First of all, the main power cable where I connect my battery has been changed to a size 12, which goes directly into the flight controller positive and negative. And then on the ESC side, I have only connected one cable directly to the PCB, from which everything else gets power. Something to note is that this particular PCB, or PDB, sorry, does provide 5 volts on all the servos and has its own BEC for managing those 5 volts. So when you connect your servos, I do recommend that you check whether or not you have soldered the correct wires for your flight controller. Some flight controllers have 5 volts directly on here, but it's switchable, or you can turn it off, or you can disconnect it. I recommend you to disconnect it, because otherwise you might fry the 5 volts. I'm not sure, I'm not an expert in this, but I just recommend you to do it this way because it's the safer way. You can choose to do it differently if you want to. From the flight controller, we have well, obviously the flight controller is using power itself, right? So then we can choose a smaller gauge wire, as well as the fact that it's shorter. We can also choose a smaller gauge wire because this one's pretty long. It needs to go all the way to the front. So these ones were part of this cable, cut down and then used, but I didn't like that because they were getting warm as well. So I changed those to a size 14 AWG. And then to the motors, I have 16. So we're going from 12 to 14 to 16. I think that this is a better way of doing things, and I have tested this. The cable is definitely not getting even nearly as hot as the original cable did, so we can just throw that away and use it for another project. And in terms of cable management, you can see that I've zip tied most of my things. One of the reasons I do this is because I want to make sure that none of the wires can easily be tugged out of position, even though that's sometimes difficult. For example, when you want to disconnect the air unit so it's not getting hot while you're doing these bench tests and stuff. I'd rather have it this way because that makes sure that everything stays in place, even when there's a bad landing, etc. I've had a situation where my GPS, for some reason, I guess disconnected or had some connection issue, and that resulted in me losing GPS a few kilometers out, which is not great. In addition to that, I have added a second capacitor. This is just so we have even more noise reduction on the main power rail. So it's exactly the same capacitor. It's a Rubicon 470 picofarad, 35 volts. It's exactly the same capacitor on both sides, and it's an excellent capacitor, works fine. The only thing that I have changed is I have added a little bit of hot glue to both the top and the bottom of this capacitor because it's very wobbly, and when you plug stuff in, they can move out of position, and obviously if you cycle them a few times back and forth, eventually it will break off and then you can throw it away. So my advice is just add a tiny bit of hot glue. I'm not a very big fan of hot glue, but in this case, I think it's perfect because you can remove it just with some pliers. It will, because it's a very nice, shiny, flat surface, it will remove perfectly. So that's about it for the internal setup. You can see wires going through to the front. These go into the gimbal nose. I need to modify the way that my gimbal works, but I need more channels, so I'll probably do that in another video. For now, it is the way it is, and the gimbal is basically directly linked. So the gimbal settings channel is directly linked to my manual / acro / horizon mode channel, and that just controls the way that this gimbal works. In horizon mode, it's a self-leveling gimbal, so it keeps the camera level all the time. In acro mode, it's like position 1 for strength of stabilization, and then there's the second position as well, which is the manual mode, but I usually don't fly the plane in manual, although it flies great in manual too. Anyway, so we'll get into the gimbal and all of that in just a moment. I will disassemble this and then I'll show you the parts so that you can choose whether you want to print this or not. Something that is interesting that I wanted to mention: when you buy the servo kit for the flaps, you do get some interesting cables, and because I have bought the cables separately as well as these ones, which came with the kit, and there we go, the GPS has just unplugged itself. So that's a perfect demo for why you might want to put some hot glue on this connector as well. But anyway, let's get back to this. So there is the option of installing stuff in the wings, and as you can see, I have chosen to add one of these wires. So we've got positive, negative, TX and RX, which go into the flight controller. In my case, that would be TX and RX7, which is where I have connected my rangefinder. And if we flip the plane around, we can see that there is a little 3D printed part which houses the rangefinder, and it just fits perfectly into one of those hatches. So that's just something that you can add if you want to. But there we go. Something has just come loose, so you know, this stuff happens. Keep in mind, you really don't want that to happen. In either case, that's pretty much it regarding the wiring setup, etc. Keep in mind the wires, make sure everything's nice and neat when you do your build, and yep, now let's move on to the 3D printed parts. So these are the two options that we've got for the T2 Cruza. The first option, and that's the default, is just standard O3 air unit, or whichever system you want in the front. I have 3D printed a small piece that just uses some double-sided tape to get stuck in there. I've also used a bit of double-sided tape to stick the antenna in, and then the whole assembly slides out. This is a very nice piece. That's just my cable for connecting. Keep that there just in case. It's really nice because you've got access to the SD card slot, you've got access to the USB port, and you can easily take this out, and it's very easy to plug back in. When it stays, you put it in, it stays, and it's good. It's a nice position. It lifts the air unit from the bottom, so you don't have to stick it to the bottom. It's nicely ventilated, and this part is pretty much open on all sides. They've actually done a very good job at designing this. Whoever has designed this has done a good job. Something to keep in mind though is that it has been designed for the first revision of the nose. Unfortunately, the second revision is slightly shorter on the sides, and you might just have to cut it with some scissors. It's very thin, so you should be able to do that, but you might have to cut the sides so that it fits in perfectly on the revision 2 of this plane, because the dimensions have changed slightly. In either case, you just connect it with a cable, you know, standard setup, nothing special. However, there is another part, and I've put a link to it in the description of the previous video, and I'll put a link to this in the description of this video as well. This is just a part that I have taken from another STL file, which I don't know why I can't find anymore online, because otherwise I would have linked the original part for that as well. And I think it has been designed for a walk snail system, but because of the way that these systems are mounted, it doesn't quite work perfectly for the DJI O3 Air unit, because there isn't much space left in the back. And so I have modified this file into essentially two pieces. One, which is this ring piece, which goes on the back like this. Original part was with this directly on the back, but what that makes is a massive surface that requires supports, and it just doesn't make sense to print it this way, so you just print this piece and then you print this piece. And when you do, it's also a good idea to split it at the front. You can see that I've got a tiny little seam right there, and that's just because this is another region which ideally would have supports, but because I don't want to use supports, it's not necessary, it's just a waste of time and material, I have just printed it like that. Some of the issues that you might have with this piece when you print it is that you will have to enlarge these holes so that it fits more easily into the front and doesn't give you some strange resistance when you put it in. The way that you install the gimbal is very simple. You can install it with this piece not yet glued on, or with the piece already glued on, doesn't really matter. It's just 4 screws on the top. If you use dome-headed screws or you know, these nice big hex screws, then you can, you know, have them nice and flush, and they fit into these holes perfectly. So you can use stuff like that to mount this. Just check the length. To take the air unit out, you just slide it out like this, and the whole thing comes out. So that is the cable that comes with the gimbal itself, and then you have access to your SD card and your USB port. Now, alternatively, what you can do is, after plugging this thing into the back, and it's just it's not a friction fit because there is almost no friction, but there's a tiny bit of, you know, wiggling back and forth to get it perfect, and then the antenna stands out like this. I like the antenna to be as out as possible, as far out as possible, and I like to use the original DJI antenna because I think it's a good antenna. But to do that, you have to kind of mount it in this fashion, which may look odd, but is actually good for cooling. And when the gimbal is rotating, you can see that it does not clash in any range of motion with the back. And you can have a look at the back if you wanted to. However, there is enough space to gain access to the USB port, which I will try to zoom into. There we go. So you can access the USB port. You just have to use a little adapter, and then the adapter can fit through the hole in the back and then fit inside your plane. So you never have to take this off if you wanted to, and you will have access to your SD card from the air unit itself. That's just an option. I'm going to put a link in the description so you can see exactly how that is supposed to look like. With the piece mounted, it should have enough space for the cable to fit. This part I will link in the description below as well as the other pieces. I might just make like a Thingiverse link where you can see all of them. That's another piece that I printed for this plane because I just liked having the ability to slip it on and off when I need to. And yeah, let's see what happens. I mean, I've been using the gimbal. I like the way the gimbal works. I'm just a little bit, you know, it's not great for vertical takeoff and landing. The reason why is very simple. When the plane transitions, you want to be able to see where the camera is actually pointed, and any of the modes stabilize that motion because it's a gimbal. It's supposed to stabilize what's happening. But then that means that you don't see whether your transition is actually happening correctly. And I've had two instances. I'll show the video of those. I've shared them in the INAV Fixed Wing group already, but essentially what happens is the plane, I don't know how, but it just flips around 360. It does literally a loop inside itself, almost. You know, it's stationary in the air, but does a loop, and the gimbal tries to stabilize that, and it just looks horrible because you don't know what's going on. The horizon is completely different from the horizon that you're seeing, and this is just something that hopefully a later revision of INAV will have, because then when you will be able to connect the gimbal via UART, it will be able to fuse the artificial horizon on your plane and the artificial horizon on the gimbal, and that's really what we want. Otherwise, this is a great gimbal. It just doesn't work with INAV yet in any of the official releases, so I hope that becomes a feature in the future. So that's about it. With this, I think we can conclude the video. I've shown pretty much all the important parts from my build. I hope that you enjoyed the video. If you have any questions, you know what to do. If you enjoyed the video, you also know what to do. So leave some comments, leave a like, share it with your friends if you believe that this was a good setup tutorial on how to set up the tilting rotors. I know that the previous video was a bit short and wasn't explaining everything in detail, but I just wanted to get it out because I thought, you know, this just needs a little bit more attention. I then wrote the guide, and yeah, let's see what happens. in either case, I hope you enjoyed the video. Thank you for watching. I know it's been a long video. If you have any questions on my INAV setup and stuff like that, please feel free to leave a comment, and I'll get back to you in the future. Thanks for watching.